All right, hello everybody. Today we're going to talk about objective 5.6, which is about finding if two lines are parallel to each other using slope. So yesterday on the Desmos we talked about parallel, perpendicular, neither, just giving graphs. We talked about how do we graph a line on the same axes, and then how do we use that information to see if lines can be parallel, perpendicular, or neither. Today we're going to use our slope formula to do the same thing. Okay, except today we're only going to focus on parallel. So in this unit, we will learn how to use coordinate geometry. We're going to start with reviewing the slope of a line. So here in exercise 1, we're going to talk about how do we find the slope of a line, excuse me, given its graph. So two line segments AB and CD are shown graphed below. Determine the slope of both of these lines graphically. Recall that the slope is the ratio of the rise of a line to the run of a line as we move from left to right along the x-axis. So basically, what that means is how many units are we going up, how many units are we going down, and we've done this before. So if I'm trying to find the slope of AB, I'm going to find 2 points that I know for a fact are on the graph. They labeled points A and B for us. All right, so let's use these just because they're labeled for us. So to get from point A to point B, I'm going to say, all right, I'm going to go up 1, 2, 3, 4, 5. To the left, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my rise is 5. I'm going up 5, and I'm going right 10. So my slope is going to be 5 over 10, but 5 over 10 simplifies to 1/2. Okay? Now remember, if you're trying to simplify a fraction, you can always simplify your fractions on your Desmos graphing calculator. Okay, Desmos graphing calculator is linked on the top of our Google Classroom, but you can always just Google Desmos graphing calculator as well. And then if you type in 5 over 10, it will simplify it to 0.5, and then when you hit this button right here, it'll simplify it even further, or not even further, it'll simplify it to 1/2. Okay, the first one was just a decimal. The second one, we have our slope, or our fraction simplified. Okay, so now we have CD. Now, first of all, CD is going downhill. If I read it from left to right, it's going to be going downhill. It's going to be decreasing. So to find the slope of CD, I'm going to start at point C. The rise, or the amount of units that I'm going down, right, is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we're going down 12. To the right, 1, 2, 3, 4, 5, 6, 7. Wait a minute, down 13. Let me try this again. I apologize. Slope of CD. We're going down 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. To the right, 1, 2, 3, 4, 5, 6, 7, 8. All right, I was right. So down 12. To the right, 8. So my slope is going to be 12 over 8, but I don't want to leave it as 12 over 8. I want to simplify it. So to simplify 12 over 8, I'll go to my Desmos graphing calculator. If I type in 12 over 8, that simplifies to 1.5. As a fraction, it's 3 over 2. I keep saying it simplifies to 1.5. It's 1.5 as a decimal, but as a fraction, it's going to be 3 over 2. Okay? Simplified fraction is going to be negative 3 over 2. Okay? Not positive 3 over 2, negative 3 over 2. Okay? The reason it's negative is because it's decreasing. If I read it from left to right, it's going downhill. Going down. Okay? Now, we talked about how do we find the slope of a line given 2 points. We talked about the slope formula. y2 minus y1 over x2 minus x1, or y1 minus y2 over x1 minus x2. In my opinion, I would just not even bother with this one. I would just focus on this one, because this is the one that we are used to seeing. And, we've been working with this whole time. You probably worked with it in Algebra 1, so let's just roll with that one for now, okay? So we're going to use this slope formula to determine if two lines are parallel. But before we do that, let's take a look at the next page. So we have studied parallel lines before in this class. So we know that parallel lines are two or more lines that do not intersect. They're never going to cross. They're never going to touch. Okay? They have a remarkable property when it comes to their slope. So let's take a look at number 2. In the diagram below, two pairs of parallel lines are shown. Name the parallel lines. So parallel lines, again, are lines that do not intersect. So my two pairs of parallel lines are going to be R and N. Okay, those lines will never intersect. And then S and M will never intersect either. Line S and line M will never intersect, they're parallel. So letter B, for each pair, determine the slope of the lines that make up the pair. You can do this graphically. So we need to find four slopes. Let's find the slope of R. Let's find the slope of N. Find the slope of S. And find the slope of M. All right, so let's find the slope of R first. So R is right here. I know that this point is on the graph, and I know that this point is on the graph. I'm going to go down 1, 2, 3, 4, 5. To the right, 1, 2. So my slope is -5/2. That's the slope of R. Slope of N, I'm going to start from here, go to here. I'm going to go down 1, 2, 3, 4, 5. To the right, 1, 2. So my slope is -5/2. For S, I'm going to start right here. I'm going to go right here. I'm going to start right here and go right here. So I'm going to go up 1, 2. To the right, 1, 2, 3. So my slope of S is +2/3. Again, it's going up. It's increasing. It's going up. So I know it has to have a positive slope. Okay, and then for M, if I start here and go here, I'm going to go up 1, 2. To the right, 1, 2, 3. All right? So what do we notice about the lines that are parallel? Well, we know that they're going to have the same slope. Now we just kind of showed it graphically. Okay, so since they have the same slope, they need to be parallel to each other. Now, here's where it gets more fun. Okay, here we know that two non-vertical lines will be parallel if and only if they have slopes that are equal. Basically, if our slopes are equal of two lines, then they're parallel to each other. All right, so given the points, A, -2, 1, B, 6, 7, C, -4, -3, and D, 8, 6, do the following. Is AB parallel to CD? So just note one thing, this symbol right here means parallel. This is very important. Okay? Okay, those two lines mean parallel. So is line segment AB going to be parallel to CD? So basically, if I plotted these points, if I plotted A, -2, 1, and B, 6, 7, you don't have to draw this down. You don't have to write this graph down. If I plotted these points, all of these points, if I plotted all of these points, letter A is asking us, is AB going to be parallel to CD? Now, by just looking at it, it looks like they might be, but that was just a sketch, and it wasn't a great sketch. So what we're going to do is we're going to use the slope formula twice. So we're going to find the slope of AB. Now let's do that. The slope of AB, if we have A, -2, 1, and B, 6, 7, I'm going to use my slope formula. I'm going to say M equals y2, and this should be review, minus y1 over x2 minus x1. Okay? Here we have x1, x2, y1. Nope, that's wrong. Don't write that. We have x1, y1. And we have x2, y2. Okay, this should all be review. For y2, we're going to plug in 7. For y1, we're going to plug in 1. For x2, we're going to plug in 6. For x1, we're going to plug in -2. Be careful when you're subtracting negatives. Okay, we have to read those two minus signs there. 7 minus 1 is 6. And 6 minus -2 is 8. And then 6 over 8 simplifies to 3 over 4. So now I have the slope of AB. Now I need to find the slope of the other line. I need to find the slope of CD. All right? Okay, so CD, if I have -4, -3 is C, and D is 8, 6. Okay, I'm going to label my X1, Y1. And X2, Y2. Use my formula. M equals Y2 minus Y1 over X2 minus X1. My Y2 is 6. My Y1 is -3, so I'm doing 6 minus -3. My X2 is 8, so I'm doing 8 minus my X1 of -4. Right? 6 minus 3 gives me positive 9. Okay, 8 minus -4 gives us 12, so we have 9 over 12. Now guess what? 9 over 12 is also going to simplify to 3 over 4. All right, so you might get 6 over 8 and 9 over 12 and say that those aren't equal. But be careful. If I do 9 over 12 in my Desmos graphing calculator, that's going to simplify to 3 over 4. If I type in 6 over 8 in my Desmos graphing calculator, that's also going to simplify to 3 over 4. So these guys have the same slopes. So since they have the same slopes, that means that these line segments are parallel. Yes, AB is parallel to CD because they have the same slope. Okay, so we can use the fact that two lines are parallel if they have the same slope given the equation of the line, or using our slope formula, either way. Okay, now last but not least, let's take a look at letter B. Is AC parallel to BD? Okay, so now if I took the same diagram that I drew before, and I connected AC and BD, now these don't look parallel, but that's not enough to write that these don't look parallel or that they don't intersect, because if I drew them on forever and ever in either direction, they probably would intersect. But let's prove using our slope formula that they are not parallel. So let's see. If I take AC and find the slope of AC, I know that A has coordinates -2, 1. And I know that C has coordinates -4, -3. Okay, so to find the slope of AC, I'm going to take my slope formula, label my X1, Y1, X2, Y2. Plug in my slope formula, Y2 minus Y1 over X2 minus X1. All right, plug everything in. Y2 is -3, Y1 is 1, -3 minus 1. X2 is -4, X1 is -2, so I have -4 minus -2. Okay, we have -3 minus 1 gives us -4. And -4 minus -2 gives us -2. And then -4 over 2, -2 simplifies to +2. Okay, so that's the slope of the line segment AC. If I was to plot the point A, plot the point C, connect my points to make a line segment, it would have a slope of +2. Now let's find the slope of BD, because we need the slope of BD as well to see if it's also going to be 2. So for the slope of BD, we need to first find the coordinates of B and D. Point B has coordinates 6, 7. D has coordinates 8, 6. They're all positive here, which we like. All right, label my X1, Y1, X2, Y2. All right. For my slope formula, plug in Y2 minus Y1. X2 minus X1. Y2 is 6, minus Y1 is 7. X2 is 8, minus X1 is 6. Okay. On the top, we have -1. The bottom, we have -2 or +2. Okay? So the slope of these guys is -1/2. So actually, it looks like these lines are actually going to be perpendicular from what we talked about yesterday, but we're actually going to talk about that later on in the week. But to answer this question, no, they are not parallel. What were the two segments? No. AC is not parallel to BD. I don't know why I changed color like that. So AC is not parallel to BD because they do not have the same slope. Okay, so if you find two slopes and they're the same, that means that the lines are parallel, okay? So ladies and gentlemen, that's objective 5.6. As always, please feel free to reach out if you have any questions. Have a great day, everybody.